Assalamualaikum student. Today we discuss the topic that is the gravitational potential energy of the chapter work and energy. First we discuss the gravitational potential energy in uniform gravitational field. In uniform gravitational field, here we take the mass in the uniform gravitational field. Here we take the object that is the mass m at a height h. So we can write it gravitational potential energy. Gravitational potential energy that is represented by GPE. So gravitational potential energy is equal to mass time acceleration due to gravity and height h. Now we discuss the gravitational potential energy in non-uniform gravitational field. First we discuss the uniform gravitational field. Here we discuss the non-uniform gravitational field. In non-uniform gravitational field, here we take the example of the object that has spherical symmetry is created the radial field. This field is the radial field. Here we take the test mass at a distance r from the earth, so that the gravitational potential energy between these bigger and smaller mass is that is equal to minus gravitational constant time mass of the earth time mass of the test mass over distance between them, that is represented by r. That negative sign shows that the if we move away from the gravitational field, here we take the negative sign. This is all about the gravitational potential energy in uniform gravitational field and non-uniform gravitational field. Now we discuss this topic, that is the escape velocity of the chapter work and energy. What is the escape velocity? Escape velocity is the velocity at which a projectile must be launched in order to escape from the gravitational pull of a massive object such as a planet. Here we write the gravitational potential energy that is represented by GPE between these two masses is minus capital G mass of the planet, that is represented by capital M, and mass of the test mass, that is small m over r. Gravitational potential energy is negative, indicate that we have to give it energy in order to free it by the gravitational pull of the planet. We can do this by projecting our test mass m by giving it kinetic energy. Here we add the gravitational potential energy plus kinetic energy. Gravitational potential energy that is equal to minus g capital M small m over r plus kinetic energy that is equal to half mv square. So we can write it as g capital M small m over r. So final equation we get v is equal to 2g m over r. This is the equation of the escape velocity. Escape velocity that depends upon the escape velocity that is represented by ESC depend on two things. First one is the mass of the planet. Second one is distance from the center of the planet.